Good evening, everyone. Let's be seated and settle in. We will be starting in about 5 minutes once our dignitaries join us. Now, just before we start, at IIT we have this culture of something called the open book test. Most of us alumni would know about it. So I'm just going to ask one such question, okay? But not for the ones at the front. It's more for the middle seaters and the backbenchers. What do you think MInT stands for? The first time I heard MInT, I thought it was my favorite flavor of chocolate. So did you think anything like that, or do you know what MInT stands for? Okay, bingo, it's there on the screen. So that's why I told you it's an open book test. But why mobility, intelligent transportation? Do they mean something different? What do you think? All right. Yes, Samrit. Okay, I see you've been very attentive in your classes, but you will get to know this and so much more, how this started, why this started, and how it all came together in the founders panel, which is planned as part of the evening's event. So in short, this evening we have an exciting lineup of programs, right from keynote speeches to panel discussions and project showcases. So we are very glad that you're here today to join us this evening, and we look forward to provide you with an opportunity to listen, learn, and engage with eminent experts in this field. As we are waiting to begin, I request Rahul to play the video of the last year's summit.
really fascinating initiative, which really is appropriate because our country is passing through a phase where it can define new frontiers. It can change the way our citizens live the next decade and the decade thereafter.
So we are at the crossroads where digital technologies are available, and how do we harness them, and how do we put them to good use?
I do feel that technology has so much to offer today. It's just an incredible time. It's a exciting time. It's a challenging time.
So once you have data, once you have models, we can start measuring the impact, right? We can do much better operations management. We can do much better transport planning, right?
Transportation is actually mode specific, mobility is user specific, and that's actually super important. We have to look at people or goods, look at track. So when somebody is actually moving out of their homes and going to their final destination, what is the different stuff that they do? Right? If a particular goods is actually going from place A to place B, what does it do? That's the kind of thing that we should be looking at instead of being mode specific.
We see a lot of opportunity in India. It's quite interesting where the government's looking to go in terms of GNSS-based tolling, and what does that look like for India, and how can we help bring our expertise to make that a successful initiative that can not only help reduce travel time, reduce congestion, but also reduce emissions and of course increase safety.
MInT collaborative initiated by IIT Madras, and given the significant impact of transportation on economic growth and sustainability, we believe that participating in this collaborative is crucial for fostering innovation, driving research, and shaping the future of mobility solutions that will benefit the society.
Of this, as far as the areas that we are interested in is concerned, I think there is a long laundry list of items that directly come from our customers that can only be solved through this MInT initiative. Be it things like sensorless cargo weight detection that we are working on, some research aspects, optimization that Geeta has alluded to before. All this, I believe this is started off and is going to become the most apt platform for solving these kind of problems at scale for the entire country.
Is that India is already a leader in solving mobility problems, and we don't need to actually look and wait for the global north to actually provide the solutions. A lot of things that are actually created and solved here can help address not only India's problems but the world's problems.
So where do I see 2050 India? Today we have about 150,000 deaths because of accident.
We will start in 2 to 3 minutes.
Check, test 1 2 3, check.
Please stand for the Tamil Thai Valtu.
நீராறும் இளமடந்தை கெழிலொழுகும் சீராரும் மதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you. Please be seated. Good evening. A global initiative to build digital infrastructure, a collaborative that brings together academia, government, and industry, and a place where mobility solutions for 1 billion are being dreamt of. Ladies and gentlemen, on behalf of the MInT Collaborative, I'm truly excited to welcome each and every one of you to the second MInT Mobility Summit. I'm Dr. Kalitha, an alumni of IIT Madras and the MC for the summit. It's my pleasure and honor to invite our chief guest, Thiru Krishnan, a member of the famed Indian Administrative Services for the past 35 years, and who has a wide experience in a range of assignments in the Government of Tamil Nadu, Government of India, and International Monetary Fund. He is currently posted as the Secretary of the Ministry of Electronics and Information Technology, Government of India, New Delhi, since September 2023. We are delighted, sir, that you could join us as the chief guest for this program from Delhi amidst your busy schedule. I also now invite to the dais other dignitaries, Professor Raghunathan Rangaswamy, Dean, Office of Global Engagement, Dr. Ramakrishnan Srinivasan, Professor of Practice and CEO, the MInT Collaborative, Professor Geeta Krishnan, Faculty in Charge, the MInT Collaborative, Professor in the Department of Data Science and Artificial Intelligence. Can I request you to please come forward for the lighting of the lamp towards the left? I invite our distinguished chief guests to declare the summit officially open, followed by the lighting of the lamp by the deans. Sir, please declare the summit open.
I'm very happy to declare the summit open.
A bigger round of applause, please. Thank you, dignitaries, for officially declaring the summit open. I now invite Dr. Ramki, CEO of the MInT Collaborative, to welcome the gathering.
Thank you, Kalita. Good evening, ladies and gentlemen, researchers and thought leaders. Welcome to the second annual MInT Mobility Summit, the premier global digital mobility summit where DPIs and digital methods are discussed to enable and implement mobility solutions. It is my pleasure to invite our chief guest, Honorable Sri S. Krishnan IAS, Secretary of MIT and the custodian of Digital India. It is also my privilege to invite the guest of honor, Sri Dr. Shivkumar Kalyanraman, CEO of Anusadan NRF, who will be joining us a bit later to give us a chief guest's address on his thoughts around what we will be doing relative to collaboration between academia and industry. It is also exciting to have amidst us the Dean of Global Engagement, Sri Raghunathan Rangaswamy, and he will be here to kind of share his thoughts on mobility as well and on the wishes for MInT. I want to start with a very warm welcome to all the researchers, students, influencers, and people who are committed to solve the mobility problems for the future by the use of technology. That is what MInT is all about. It's actually amazing that a year has passed since MInT started. There's a lot to recap and reminisce. A special thank you to the founding members without whom this would not have started. A number of them are actually seated in the audience in front of us and who will be joining us for a roundtable to kind of share their memories and their aspirations for the future for MInT. This year's summit's theme is AI in mobility. We aim to explore in the next 2 days the digital world that we want to create and understand where AI becomes a critical enabler to build it, run it, and to solve our very real problems in mobility. We will have an amazing tete-a-tete to start this off, where Professor Travis Waller from TU Dresden and Professor Parthasarathy from OSU, both experts in the field of mobility and artificial intelligence, will duke it out on where AI comes in shaping the digital mobility of the future. So let's get started. I wish to invite Sri Krishnan to give his inaugural address and his thoughts and vision for mobility in a digital India. Sri Krishnan.
Good evening to all of you, and apologize for not being able to be present in IIT Madras with all of you in person, primarily because of other official commitments here in Delhi, and I'm unable to come away. But on the last occasion that I visited MINT's facility, the newly minted facility of MINT, literally, in IIT Madras, in the Vadhvani Center, I was duly impressed by all the work that they are doing. And of course, even before that, MIT has been closely involved with the Civil Engineering Department of IIT Madras in working on various projects relating to mobility and the integrated transport systems, ITS projects. And therefore, I think this is a logical progression of the kind of partnership that MIT has had with this particular team on the kind of work that needs to go into applying technology to mobility issues. MIT's basic mission is increasingly to ensure that technology and technology solutions are applied across a range of applications within government and for problems and issues which affect society as a whole, which affect communities as a whole and the country. And in that sense, mobility is a very key issue, especially in urban areas, especially to make sure that people have a easier ride through their day's work, are able to reach where they need to, and if we are able to, through the application of technology, truly make it a passenger-centric or a citizen-centric mechanism, which ensures that they are the ones who are convenienced the most, and at the same time, through that mechanism, achieve the larger public goods, which are very important in the context of transportation, which is basically reduction of pollution, reducing the time lost in transportation, making sure that it is a productive enterprise overall. All of these are critical factors in modern day living and critical to enhance overall productivity. And that is where I think application of technology becomes important. And as we move along and as technology improves and we have newer technologies emerging, and as artificial intelligence is emerging as a horizontal technology which can be applied across the board to a range of applications, urban mobility is also clearly a space where such a technology application needs to be seen. And I'm extremely happy to note that the Mobility and Intelligent Transportation Collaborative, MInT, as an initiative, and it's a global initiative today, and is aiming to achieve some of these larger goals, including a 50% reduction in the total emissions from transportations. So making it a sustainable form of transport, a reduction of road fatalities, and which is, accident prevention, which in the Indian context is extremely important, is vitally important, given the number of lives and well-being which we lose to accidents every year. And of course, in terms of energy efficiency and making sure that consumption of various forms of fossil fuels is reduced considerably through improvements in technology and transportation. And I'm glad that in each of these areas, MInT aims to apply technology, apply artificial intelligence, and try to find ways to achieve these overall goals. Clearly, this is research which needs to be done in conjunction with industry, needs to be done in conjunction with various public agencies which are engaged in the transportation sector, so that we see genuine results which can be replicated elsewhere. Today, the other issue is that very often, even for these overall applications of these technology, which has so many positive social outcomes, the costs often are prohibitive, and many urban local bodies, many regional development authorities, and even state governments are unable to spare the kind of resources which is needed to make mobility more seamless and more sustainable. And that is where I think MINT's efforts to develop almost what could be a digital public infrastructure could make such a big difference. In the Indian context, we've had a number of DPIs which have been developed, starting from Aadhaar, UPI, and a whole host of other DPIs, which have been developed through public-private partnerships, through initial public investments, which have then later on proved to be launch pads and platforms on which more innovation can be developed by startups, by innovators, by the private sector, thereby delivering a lot of value to the final consumers. So to some extent, the fact that the public sector subsidizes the initial digital infrastructure which is required for such a venture is an important launch pad from which a number of commercially viable enterprises can be launched, and at the same time, overall public good can be enhanced. And that's how innovation keeps building on innovation, and we are able to really deliver results through application of technology. And I think that is something which will make a very key difference in the efforts that MINT is making. I understand that they would be working on solutions like adaptive traffic control, traffic management, bus prioritization, parking solutions, trip management, etc., across different Indian cities, and the contribution that they make will be significant. I have myself attempted to implement programs of this nature. They are implemented with the kind of technology which is available today. It is very expensive, and not many cities can afford it in normal circumstances, which is why it is important to develop lower cost solutions in this area. Likewise, the pattern that is being, the attempted platform that is being built, which is the Bharat Multimodal Mobility Stack, will foster both for a build for India and also solve for the world goals. It basically attempts to define mobility as a digital public good and serves as a benchmark for standardizing, developing, and deploying mobility tools and services intended for everybody. It's an inclusive and democratic attempt where everybody can actually use a tool of this nature and work on this. This stack will encompass all dimensions of mobility at the grassroots level and cover various areas like establish the standards of interoperability, establish standards for infrastructure development, look at multimodal connectivity, look at advanced vehicle technologies, and see how resilience can truly be enhanced. I think this is a truly commendable effort. It's also a multidisciplinary effort in what is being attempted to be done by a range of departments from IIT Madras in this case, and eventually, hopefully, from across different institutions in the country. I understand that the center itself, when I visited there, has nearly people from 15 different departments and disciplines in IIT itself, and which I think is truly a very important way in which, interdisciplinary way in which different disciplines can come together, and thereby also ensure that you have a platform which works across different providers, even at a city level. I mean, there could be multiple agencies involved, and achieving the coordination and cooperation of multiple agencies is always a challenge. And the coordination issue will also need to be addressed through such a platform, and that is precisely what is being attempted. And I think it will make a really big difference in the way that it works. And of course, everything today is based on artificial intelligence in terms of where the potential of using artificial intelligence comes in. And that is something which, again, applying different types of technology and using different technology comes in a big way into this mechanism. And I expect that this particular summit will offer a range of stakeholders, whether it is startups, whether it is industry, whether it is government, whether it is academia. And I also understand it's an international event, so we have participation from other countries as well. And I think it'll be a wonderful occasion to exchange ideas. And MIT as a ministry would really look forward to the outcomes of this particular event as to what recommendations would get made, what kind of new ideas will come up, and the way in which we can actually then look to establish these applications which would come up. We are in MIT building up the India stack and also the global depository on DPIs. And India has taken a lead in this area. And if this particular summit eventually leads to more DPIs being developed in this important space, we would be very happy to support that development and to take it forward to the next stage. So let me wish participants all success, and I wish the organizing team, all the industries who are there, and all the stakeholders the very best for this summit. And as I already said, we would be very eagerly looking forward for the outcomes of this summit. Let me congratulate all the organizers once again for the work that they've put in, and wish you all the very best. Thank you very much.
Thank you, sir, for sharing your perspectives and enumerating especially what is happening in the Indian context, aptly setting the stage for the summit ahead. I now invite Dean Raghu to share his thoughts.
Thank you so much for inviting me. It's a pleasure to be here. IIT Madras in the last 15, 20 years has been going through a sea change. I just don't want to throw statistics at you. But many research efforts are being integrated and consolidated into larger efforts that can have an impact. And that's been the mantra for IIT Madras in the last few years. We have the very successful Energy Consortium, which was the first consortium we started from the IOE times, which has been incredibly successful, many companies participating in it, and many things that have happened. And now I see more and more consortiums being formed. I think MInT was the second one. And when I asked Geeta whether I can call MInT a consortium, Geeta said, no, it's a collaborative. So I said, what is the difference? He says, consortium, you only get money from people. In collaborative, you'll get both money and work from people. So I think he's gone one ahead of Energy Consortium. And I thought after the COE reviews that I just finished, I will recommend everyone start a consortium, but now I'm going to say everyone start a collaborative. Get more money and work out of people. I just want to say something about AI in IIT Madras. IIT Madras being a technological engineering institution, it's really heartening to see that while AI and the fundamental AI work happens here at IIT Madras, it is also really being applied across all domains. And that's truly what sets IIT Madras apart in terms of the AI initiatives. While we have, for example, the amazing AI for Bharat work in Bhashini, the largest multilingual data sets available in India being developed at IIT Madras, we also have AI in healthcare. We have an AI model for Indian population to predict preterm birth through a cohort of several pregnant women in northern India. So that's actually in healthcare AI actually being implemented. We have the Walmart Center for Tech Excellence where we have AI being implemented in MSMEs. And we have MInT where AI is being looked at transportation and so on. So really the idea of not just looking at developing AI algorithms or talking about AI applications, but actually going headlong and then saying, I'm going to implement AI solutions at scale is the difference that I see at IIT Madras. And I'm really hoping that this MInT collaborative will put AI solutions on ground like other initiatives that have happened. So that's the most exciting part for me being here. And Geeta, in the short time, has done wonderfully well in putting this together. And I hope this goes from strength to strength. Most of the times nowadays, as Dean Global Engagement, I give some numbers and so on. But in this particular thing, I also do some work. We have our mobile sensors which can identify pollutions. And we are looking at ways to develop highly hyperlocal pollution information and also road condition monitoring and so on. So once my deanship is done, hopefully I can also technically contribute something to you guys other than just coming here and giving introductory speeches. But in any case, I'm really happy that this second edition is happening. And I hope that it goes from strength to strength and you really make a difference for mobility, which is absolutely needed in India. Any one of us who travels knows we do need it. And I hope you guys make a difference. Thank you.
Thank you, sir, for sharing a holistic view of how AI is at work within IIT Madras. I request Professor Geeta to share a token of appreciation to Dean. Please come to the front. May I request you to please come to the front of the stage. On behalf of the MInT Collaborative, I thank our honorable chief guest and Dean for sharing your thoughts and the inspiring words with us on the dais and for your presence at the inaugural function. So it was an honor to have both of you, and with this, we will officially conclude the inaugural session. Please stand for the national anthem.
जनगण मन अधिनायक जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you. I invite our guests to please take their seats below and to enjoy the rest of the proceedings. Okay. So next up, we have a very interesting panel discussion that is called the MInT Founders Roundtable. Now, a very famous quote by Helen Keller. Okay, a famous quote by Helen Keller on collaboration goes like this: "Alone we can do so little, together we can do so much." And I think this is the exact spirit that unites the diverse ensemble of industry partners that make up the MInT collaborative, all who have come together with an interest in using technology to solve everyday mobility challenges. To give you an overview of the founding members, we have 2F, which is a global technology company that offers integrated solutions for vehicle manufacturers, mobility providers, and startup companies. A very interesting line about them that I read is that they are enabling the next generation of mobility vehicles to see, think, and act. Sintra is one of the largest private developers of transport infrastructure in the world. They are also developing innovative solutions to meet global mobility needs. Third is Interrise, a leading infrastructure investment trust committed to redefining global standards in the operations and maintenance of Indian highways. Zera Robotics is the first e-boat manufacturing company in India for sustainable mobility. And the fifth, very interesting name, which goes You, Me, and Us Technologies, where they are looking to reinvent technologies to create sustainable next generation freight and transportation and logistics infrastructure. The MInT Collaborative is deeply thankful to its founding members for generously giving of your time and funds and support in building the collaborative to what it is today. And now we have as representatives to join us for the panel, both online and offline. As I read out your names, I request you to please come up to the table for the discussion. So we have Mr. Ganesha Murthy Arumugam, Head Engineering ZF. I just learned he's also an IIT Madras alumnus. Then we have Mr. Jason Soria, Innovation Engineer Sintra. Next, Ms. Hemalata, VP and Head Commercial, Interrise. Welcome, ma'am. From Zera Robotics, we have Mr. Mohan, CEO of Zera Robotics. And we have Mr. Suresh, Director, Customer Relations from You, Me, and Us. We also have Mr. Krishnan, Program Delivery, IIT Madras. I invite the moderators of the panel, Mr. Ravi Chandran, retired MD and startup advisor, and Dr. Ramakrishnan, CEO MInT, to the stage. So with this panel, let's directly hear from the founding members on their aspirations and plans in building a digital world that will enable the future of mobility in India.
So Ravi, do you want to get started with the first set of questions?
Yeah, thank you. Thank you, Ramki. Good evening to all of you who are present there. We have a very great start with a stimulating discussion presentation by Mr. S. Krishnan, followed by Dean Raghu, as always, witty and very informative. We now start with the first session of this 2025 MInT Summit, which is the Founding Members Roundtable. The introduction of the 5 founding members has already been given, so I'm not going to repeat that. So, and also the objectives of this mobility and intelligent transportation have been amply explained, so again, there's no need to say anything. So we straight away get into the inaugural, founding members roundtable. Next 30 odd minutes, what me and Ramki will try to attempt is to get each and every panel member present here as well as virtual, the founding panel member, to talk about their thoughts and experiences and of what mobility means to them in the Indian context or in the global context, their perspective, their insights, and the challenges, the opportunities in the space that they are working on first. And I think that could be done by inviting each one of you to speak for about 2-3 minutes on this subject. We'll follow that with comments from Mr. Krishnan Karungani, Program Delivery at IIT Madras, who will give his perspectives on what he has been working on. We'll go on to Dr. Geeta Krishnan, faculty lead for MInT and a senior professor at the newly minted Desai department, to talk about the initiatives with the government of India and the other state governments, as well as what we have been trying to do in MInT in the last 1 year, followed by what we're planning to do in the next year. And finally, we'll go around once again to each of the panel members to ask them to identify research topics for the collaborative that you would like MInT to delve deep in. So, Ramki, if you can take over and ask each panel member to start giving their opinions and experiences and aspirations, then we can get going. Thank you.
Thank you, Ravi. Before we get started, I think the team has compiled a video with a lot of the memories that we've had in the last 1 year. So maybe we can get that rolling first so that we kind of recap.
Check.
So Rahul, yes. Wonderful. That kind of has brought up so many memories for the past year, things that I think back, oh, did it really happen, right? But I want to start out with Hema ma'am, right? You know, when MInT started, and I think Professor Geeta was kind of talking to you all and getting you on board. What struck you? And you have become the first cheerleader for MInT, right? So would love to hear what resonated with you and why you wanted Interrise to become part of MInT.
Good evening all. Firstly, I would like to congratulate and thank the MInT collaborative team, Professor Geeta Krishnan and Dr. Ramki. What do we mean by MInT for Interrise? All of us talk about infrastructure as the physical assets. And when we looked at the long-term performance or as a user, what is it that we can add value to the people who are there on ground, the millions of users every day who use our infrastructure. The physical infrastructure is something where one part of it is on the digitization of how do you improve safety. I mean, we were still trying to find the right space or the right structure or the right kind of skill sets to map and marry both of these. Safety was going in one track and all of us had an ambition or overreaching idea that we'll have to use AI or digitization in ensuring that we have a very safe highway for all of us. If you put ourselves as a user, only then we'll be able to appreciate the importance of safety. It just takes a couple of seconds for any untoward incidents to happen. And we strongly feel at Interrise that the users should not be the persons who have to be responsible for the safety. The highway infrastructure provider have to be responsible for ensuring the safety of the road users. So the need of the hour is on us to find out innovative solutions, use the data which we have, find out patterns, understand the exact measures which we have to do. Definitely ministry headed by Honorable Shri Gadkari ji is doing a great job on the safety part, and we would like to do as an additional collaborator. We say that it's a triangulation of academia, industry and government. So the same triangulation, we just thought like, why don't we start on it? And I think when Professor Geeta approached us with this, like we are still trying to evolve something which I think our own problem statement during the course of the panel discussion comes like the way we have envisaged it and the way it has reached out. I think it has taken a year to get to a conclusion, a logical conclusion on how do we want to handle the problem statement and the expected solutions which would benefit the industry as a whole. I think that's our aim and ambition, and hopefully I'm sure we'll be able to get something concrete rolling for the entire highway infrastructure. Yeah.
Thank you, Hema. Moving on, I mean, it kind of resonates that safety is such an important part, right? And Mr. Ganeshamurthy, you would probably agree with that. And ZF kind of has a strong safety kind of theme in its DNA. And you come on board with some of those thoughts as well, right? Yeah. And you're, of course, in the automotive space, not running tollways. It's a very different place, but the vehicles. So what are your thoughts on why you became part of MInT, and you know, what are you envisioning?
Yeah. Well, actually, I think it started like the Dean was talking. We came here for the energy consortium. There we met Ramki, and then we were talking about. In fact, we had a joint exercise, Professor Krishnan, that we want to shape up various projects. And then one thing that came was how do we drive safety on Indian roads? So that's how the whole thing came up. And then it actually very well resonates with ZF's vision of how do we drive safety and how this next generation mobility is actually facilitating this vision. And because we had started this homework some couple of years back, anticipating that many new technologies are coming up, and what it means to the public. So then we started getting the initial pulse that we have put about close to 300 odd vehicles across the India. Just started getting the pulse of the safety incidents from the roads. Then we found that once in one vehicle out of 3 in every week or something, we found that a major accident is getting recorded. And we found that the systems that we put in, it actually supersedes the driver, and without driver intervention, the vehicle is getting into safe zone. So I think this was a big finding for us. Then we found that how do we take it up to scale, because you know that India is a regulation-driven market. So you can't impose a technology or a solution, even though it is benefiting to the society. Then we thought if you want to take it to the scale and to the mass, I think a kind of collaborative is very essential. And I think when we also see the other founding members, everybody is bringing some flavor to the same topic in different forms. I think this digital stack, what we are trying to achieve together as a team, I think we feel that the technology solutions from the safety aspects we bring will add more value. I think what we currently do directly with the OEMs and OEM go to the public, it will take a long time. But I think this way, when you collaborate with MInT and then do that, I think we see that this will accelerate the reach to the public. So that's actually one of the motive why ZF is willing to part of this as a founding member, I would say.
Wonderful.
Yeah.
Thank you very much. Yeah, thank you, Mr. Ganeshamurthy. So the theme of safety and then how to take it to scale. And as Dr. Kalita was talking about, how when we work on something together, the output is more, right? And how do we scale it up, right? There's another very big dimension, building vehicles, running tollway roads, right? That's one dimension. But how do we build the infrastructure around it? So I'm going to go to Jason next from Sintra. As we look at infrastructure and as an enabler in terms of creating digital solutions, connecting the vehicles, connecting the people, as well as how do we move goods and people safely, right? What are your thoughts, and what prompted Sintra to become part of MInT?
Hello, thank you for introducing me, and also thank you for the opportunity, Dr. Ramki and Professor Kita, for me to speak today. And what prompted Sintra to join the MInT Collaborative is very much to learn, to collaborate, and to also innovate. And around that, we, as Sintra, deal with intelligent transportation systems. And a lot of times, we're trying to push the boundaries of what we are capable of doing and what we can do to serve the people who use our infrastructure. So we're very interested in topics such as barrierless tolling, using advanced ITS, intelligent transportation systems. And very much so, we want to see how we can take that further. How can we bring that to a place like India, where we have a lot of different problems, different contexts that we have to approach very carefully and thoughtfully. And so being part of this collaborative, we're very excited to learn how others are approaching solutions to add to the digital public infrastructure. And we're excited to see how Sintra can also contribute to that initiative, seeing how, as highway operators, we can add to what citizens in India can expect from their infrastructure. And so very much, I talk a lot about tolling, ITS, but that should also connect to the wider ecosystem of use cases. So bringing all of these things together and understanding Sintra's roles, but what everybody else is doing is our main objective and goal here at the MInT Collaborative.
Wonderful. Thanks, Jason. Thanks for sharing that. I'm just going to kind of change the flavor of the discussion a little bit. We have with us Mr. Krishnan on the panel, right? Krishnan has been working relentlessly in the field of AI and language, natural language processing. But I'll tell you one thing, Krishnan has been at the back cheering us, pushing us along at MInT as well, in terms of how do we build a stack at scale, and how do we actually bring AI together to innovate and to kind of create the solutions for the future. Krishnan, I want you to share, how you got engaged with MInT, not as an industry partner, but as a well-wisher, and you've seen the kind of progress, right? Maybe you have some memories as well to share, right? So it'll be wonderful to kind of think and hear from you from that perspective.
Because at the outset, I just wanted to thank every member of the MInT collaborative, right? Specifically the core team, Dr. Ramki, Geeta Krishnan, Rama Balachandra. I think I bugged them a lot with a lot of ideas. I used to post Slack comments at probably at 10 o'clock and kind of bug them on a lighter note. But I think my interest in mobility came from a discussion we had when my cousin was building a startup in 2013 when he started, right, kind of stuff. And we had a conversation with Mr. Arul, who will probably be there tomorrow. He's part of the Namakkal Lorry Owners Association president. Okay, and that kind of triggered, and I just was reading up a little bit on this kind of context, right? And those days, I think digital was still a very early stages of this thing, right? So when actually this whole trigger started the FedEx Center of Excellence, and I know that Professor Geeta Krishnan was involved in it, and I was also exploring to learn a little bit more and on this topic. But coming as I just want from a MInT point of view, where I was coming in was from a use case point of view or a user point of view of a user of a service, right, kind of stuff. So what some of the aspects which I wanted to kind of outline in this conversation is, I think MInT is probably aligned with three broad areas. If I just define mobility as I want to go from A to B, right? I need safety in the right. I have to be on time, and it has to be affordable. Okay, and affordability is a big thing, and it has efficiency and other things embedded in it, right, kind of stuff. And of course, today's world, I think it also has to be sustainable, right, kind of stuff in a broader context. So what I also realize is MInT also looks at, though it's not explicitly stated, it looks at 4 broad E's, right, if I can call it. Of course, engineering is the core to it, but there's also an economics in it, right? There's also an environment in it, and finally, it's probably the user experience, okay? So this is the crux of it, and this way, as we evolve through some of these projects. So one example I want to call here is, I think Professor Geeta Krishnan will be talking about it, is the bus priority signaling project, right? Which is a very interesting project to see how you can move the public transport faster, right, through the while giving priority to it, while kind of also ensuring that the other vehicles are not stuck. Interestingly, for those of us who have taken the public transport, just as an example, right, in 90s, if you want to go from Tiruvannur to Paris, it used to take 20 minutes. Okay. Today, I don't think you can imagine that. Maybe if you're lucky, you'll get it in 1 hour in peak times, right? And this is a very fundamental, if you look at it, this is a fundamental shift, because I also read somewhere recently that there's 1 lakh private vehicles getting added to Chennai every month. Okay. And one of the facts we look at is the road space has probably is not grown at that pace. Okay. The other interesting factor is, I think if you look at it, the small cars are disappearing from the road. Right? Now you have more major SUVs which are probably taking about another 30-40% of the road space, right? In compared to small cars. Of course, there are a number of two-wheelers also, right? This is one aspect which I want to highlight. Now, so the other project which is a very interesting thing, which I think is a very, this is a conversation I had with somebody in the agriculture space, and one of the factors he was saying was, it's very difficult to transport perishables, right, faster than the farm to fork. Okay, and when you talk about the digital twin, it probably is not just about data, right? I mean, data could come from multiple sources. It could be IoTs, cold storage. Where do you push in the cold storage? How do you ensure that the goods are moved faster? What is the most optimal multimodal option to transport, let's say from Trichy to, let's say, Shimla, for example, right? Again, coming back to safety, affordability, and on being on time, right? So this is another factor to look at, right, kind of stuff. And where a digital twin can play a lot of importance kind of stuff. Just drawing back on, as Ramki sir said, I work with AIFR Bharat, I think, okay, and one of the factors we learned, we have done a significant data collection, almost about 1,000 hours of all the 22 Indian languages, right, kind of stuff, for the speech recognition. So one of the factors we realized is data is the key to the whole process, okay? Models are the glamour component of the AI engine, but data is the core, right? So three factors I want to highlight from that experience is data diversity, which is a very important point, which also applies in mobility because our traffic is very heterogeneous in terms of vehicles, right, from smaller TVS 50, or, I mean, of course, the mopeds have gone, but still there are there, to some very sophisticated Porsches today, right? Earlier used to be Audis and Benz. Today there are Porsches and Jaguars, right? Even in Chennai, right? So kind of, so there's a shift. Safety is also one of the factors I think mentioned, is safety also changes based on the vehicle. So these are some of the factors. So what I realize is how do we bring all these pieces together is an important point. So there is a need to think holistically in terms of how do you connect the dots. And that's why the collaborative plays a very important role, because different teams bring in different kind of experiences and this thing. And how do you make this into an integrated whole is an important point. Data, again, I just want to touch the other 2 points, which is basically data sufficiency, which is also a very important factor, right? The more the data, even in the LLM space, the more the data, the better the accuracy, and probably it will also reduce the hallucinations which you see typically, right, kind of stuff. And finally, data quality. This is probably the most commonly used terms, right, from CEOs down, right? But it's very difficult. It's a kind of work where it takes a lot of hard work, okay, and people may not get, or the teams may not get credit for it. But that could be the core to the accuracy of the mobility system or integrated mobility system. So just to sum up again, as I said, there are safety, time, being on time, and affordability, right? How do you bring the engineering, economics, environment, and the user experience together? I've seen some glimpses of it in the first year 1, and how do we take it to the next step in year 2 and beyond, right, is what I wanted to convey. Thank you for this opportunity.
Yeah, thank you, Krishnan. He always has a million ideas. So when he comes into the MInT space, he's always making us think. Now, one idea one thread that you touched on was efficiency, right? So here we have Mr. Suresh, who comes from a very different world, a startup world, right? And he is envisioning, along with his company, solutions on how to make things more efficient at ports, right? So again, Suresh, you got pulled into MInT, not understanding what we were trying to do. We were kind of looking at the solutions that you were looking at. And then you said, Ramki, I think this is where I belong, right? So can you kind of give us that thought process and go back in memory on why you wanted to join MInT?
Yeah, good evening, everybody, and thanks to Dr. Ramki and Professor Geeta for bringing us into MInT. And well, as Ramki says, we are a startup which is prima facie focusing on intelligent alternative transport system for freights from ports to the hinterland. And that too, our main focus is on sustainability. Now, sustainability is our focus. So basically what we are bringing out is alternate infrastructure solution other than road and rail, because everybody knows what road and rail is as far as movement of cargo, but we are bringing in a different mode which is totally disruptive, which can reduce your logistic cost by almost like 50% and your carbon footprint by 90%, and that's what we are looking at it. So it involves a lot of infrastructure development, but it also involves a lot of digital interface and a lot of AI and things like that. So we felt when we got this invite by MInT, we felt, okay, infrastructure part, we know exactly what we are doing, we know the technology which is available, and we know what can be brought in from various sources. But from the interface and where the technology or the digital part comes into picture, and that's where we felt we could be working with MInT, and we can collaborate with MInT, and we can take some advantage out of it and also give the kind of perspectives what we have. So that was with that open mind, we said, okay, let's get into MInT and see what comes out of it. And we are very happy for the last 1 year, the kind of interactions we had, the kind of clarity we got into many areas. I think that's a good experience we are looking at. And going forward, we have a very clear path where we want MInT to be, because in next 6 months' time, we are likely to get some good contracts in some of the port projects. So definitely there'll be going to be a lot of interface and a lot of discussions, and things will be required to make it kind of a product. So in our solution, what comes out as a byproduct is safety, time, and affordability. That's a byproduct which we bring in. So that's how it is. So that's the thing. Very happy to be here. Thank you.
Wonderful. Thanks you. We have Mohan Krishnan online, right? He also represents a startup, but in a very, very different domain, right? Where they're thinking about solutions for the water world, right? When they're looking at aqua systems, ocean systems, drones, water drones. So Mohan, what prompted Zera Robotics and yourself to kind of say, okay, hey, I have to be part of MInT, and what are you learning as being part of MInT, and what has the experience been, so on?
Hello, very good evening, everyone. Yeah, so we are working on a sector, and a special sector, maritime mobility. So the major reason we started been upon.
Yeah, he is actually testing out something in Kerala in the water. He's actually speaking from a boat. Okay, so Mohan, are you still connected? All right, we'll come back to Mohan. Rahul, maybe you can track him down again. Okay, so we'll hear from him. But I'm going to kind of move the mic to Professor Geeta Krishnan. Okay, so Geeta, you are the inspiration behind MInT, or at least the driving force, right? Okay, so we started from scratch, thinking about this idea. So what has your memory and journey been, and are you happy with where you are today with MInT?
Ramki, I'm happy most of the time, right? So it takes a lot to make me unhappy. But having said that, we have Dr. Shiv Kumar, who's joined us online, right? He'll be our guest of honor speech next, right? So Shiv was actually in the panel which evaluated the Institutes of Eminence, right, proposals. And Shiv actually told us, Geeta, you're not looking at data. There is so much of data. There's so much you can do, right? And that actually was one of the triggers for MInT, right? We came back and we were thinking what to do, and that's when the alumni group connected and things started rolling, right? So we'll definitely hear from Shiv next. So I just want to acknowledge, put it out there, Shiv. Thanks a lot. The inspiration has come from a lot of places, right? I always consider it, really an honor to be here in IIT to work with students to do these projects. But inspiration has been coming from all directions, and we are seeing how best to make it work. I know, ma'am talked about how it's taken us a year actually to figure out, right? If you remember the first mobility summit, we had the secretary from telecommunications department, right, Dr. Neeraj, join us. And about a month before that, he actually said, Geeta, we are also launching something called the Sangam Initiative, right? And we're going to roll out soon. And apparently we'll have some of them join us tomorrow. It took them 1 year to actually get it going, right? So, in the olden days, you had to crank up the engine to get it started, right? I think we've been cranking it up. And now that we've got this going, I think we have a very huge team, great collaboration. It's going to be like the Jagannath Rath Yatra, right? It's going to be a juggernaut, right? I think the momentum will build. We will solve big problems, right? That's something that I'm more positive about today than where I was a year back. And just a couple of points on what Ravi was also alluding to, the government interactions. So it's been fantastic talking to all the government departments. Some of them will of course join us online, and tomorrow we'll have the Kumta member secretary join us in person.
what we've found everywhere we've gone to, I've started pulling Ramki along for these meetings as well, and wherever we've walked in, they're all talking similar language. They're all talking about similar aspirations, similar needs, right? And so I think it's a great opportunity for us. Industry is already with us, right? They're walking along with us. There is a lot of, I think, students waiting to solve problems in academia, right? And if we can also get the government to join and implement these solutions together, right? When we actually see what you create work in the real world, that motivates us further, right? And that's what, closing the loop and getting energy out of it and jumping into the second year, right? I'm really excited, looking forward to that, Ramki.
Wonderful, wonderful. So, Kalita, how are you doing on time? Oh, we've overshot by 5 minutes. Okay. Always these panels have a lot to share and contribute. Let's do this. Okay. We'll go around 30 seconds each. Okay. What is your dream in the next 1 year for where you would like MInT to go? Just 30 seconds.
I would say that we should see something. I would say that we should now come to shape. We had enough deliberations, enough talkings. Now I think we should bring something on the table which can be rolled out and people start seeing the benefits. That should be my view.
My aspiration or the expectation from MInT would be like where we had started, a clear policy white paper with a way forward for literally a nationwide system to understand, implement speed calming, and also enforce measures to close the loop. So that's where we look forward.
Thank you. Jason?
Our aspirations for MInT are to continue to find ways to collaborate and to share ideas. One of the ideas that we were talking about earlier that you were also part of was the V2X journey and trying to figure out where can we best implement this type of technology, how fast can we grow. So with that in mind, I think to summarize our aspirations, it is to take some of these bigger ideas, dissect it down to these smaller problems, and as the chief guest earlier said, build innovations upon innovations.
Wonderful. Thank you, Jason. Suresh?
Our aspiration is basically to find solutions, which is very simple, intelligent interface between various modes of transportation. So that is our aspirations, and I think MInT is the only place where we can look at that and happen it. That's it.
Wonderful. So DPI for vehicle to the infrastructure.
Yes.
Perfect. Yeah. Krishnan, you've seen us 1 year. Where do you want us to be next year?
Yeah. My dream would be that we are able to demonstrate something on the multimodal side, right? Multimodal, maybe just a pilot, right? Which we can scale in year 3, right? Kind of stuff. Okay. It could be for passenger or freight or both, right? We're able to demonstrate on a small scale, even at a state level or a regional level kind of stuff. Okay. And which touches on this. That could be a great start because that's where we probably will go in terms of ensuring all our, including the sustainable SDG goals, which MInT wants to look at, right, in the long-term basis.
All right. Geeta, where is the inspiration and the aspiration?
So I think, we now have multiple projects lined up. And I think, like we had a discussion earlier, now we need to get hands on the keyboard, right? Start writing out the code, building out the DPI. And I think if we can demonstrate a few of these with the support from the government, we'll be able to scale it up nationwide. So I see this as a year of action, and maybe later half take it to the government and scale it up.
So year of action and scale. Wonderful. So I think we'll see some inklings and the kind of hints on some of those things tomorrow as well. There are a couple of projects which you would be very surprised to see in terms of what we've been implementing. So we are looking forward to that. Ravi, you are our mentor-in-chief, right? And you've been kind of the guiding light behind us, right? Bringing alumni together. So Ravi, any closing thoughts for this roundtable?
Ramki and Geeta, wonderful first year that both of you have steered MInT into. The motivations of the founding members and their aspirations, I think, forms the bedrock for the next year's plans, and draw them into projects that we've been always dreaming of, so that you can actually meet your goals of mobility for 1 billion. Thank you so much to the founding members for being here and supporting us. And we hope that in the second year, you'll see a lot of action as Geeta has promised. Thank you.
Wonderful. Thank you. Thank you, everybody. Over to Kalita to kind of take us to the next stage.
Thank you, founding members. The passion and the shared values that has weaved together the genesis of MInT is truly inspiring. Thank you for being here and for sharing your thoughts with us. I now request Professor Geeta Krishnan to just hand over a small memento as a token of our appreciation. Yeah, by then we would have the next speaker online. Has he joined?
Yeah, I'm here.
So maybe the chairs can be moved, right, so that the online members can also stand in, yeah, so that they will also be. Okay. One photo op, so that with the background of the online members as well. Please step in front. I can see Ravi smiling. Thank you. Thank you. May I request you to please take your seats? Thank you. So we have come to one of the most awaited moments of the event. And I think Professor Geeta just gave us a hint about that, the keynote address by our guest of honor, Dr. Shivkumar Kalyanaraman, who is the CEO, Anusuddin National Research Foundation, Government of India. Dr. Shivkumar is an exceptional technology and business executive who has tremendous impact measured in the hundreds of millions of US dollars across many countries, including India, APAC, Middle East, and Europe. Previously, he was CTO, Energy Industry Asia at Microsoft, Executive General Manager at GE Power Conversion, Program Director of Special Initiatives at IBM Research in Bangalore, and Chief Scientist at IBM Research in Australia, working on natural resources, supply chains, clean energy. We welcome you, sir, to share with us your thoughts as part of the keynote address.
Okay, first, this entire screen. Okay, can you hear me? Just wanted a quick sound check.
Yes.
All fine? Hello? Can I get a quick sound check? Are you able?
Yes, we can hear you.
Yes. Okay. That's all I want. Okay. Thank you, everyone, and thank you for the kind introduction. In the brief talk, I'll give you all an introduction to ANRF, Anusandhan National Research Foundation. I've just recently taken over as the CEO a few weeks back. And so this is a new organization. I'll explain what it is. The goal is to serve as a catalyst for India's rise as a research and innovation powerhouse. This is a statutory body of India presided by the Honorable Prime Minister of India. Right? So you might be wondering, hey, this sounds quite unusual. What is it? Right? So it is quite unusual. It is.
Shiv, I think if you can swap the screen, I think we are seeing the notes on the next slide screen. If you can go to display settings and say switch. Yeah.
All right. Is
Thanks.
it better?
Yeah. Thank you.
Okay. Good. Yeah. Thank you. Okay. So ANRF had its genesis in the National Education Policy 2020 as a full chapter on it. It was envisioned as a national science foundation for India, aiming to go beyond the current funding models and support also this interdisciplinary sciences, drive excellence in capacity building in our university ecosystem. That is the primary goal as an NSF for India. And over the period between the Act, the NEP 2020 and the Act, which was in 2023, and further governing board commentary, it has assumed a flavor of not just more broad-based funding, but also doing special projects. Oops, I have a power cut here. That's interesting. Okay, so also doing missions and other special initiatives as well. First, a quick check. Are you guys able to hear me? All right. Hello.
Yeah, we can hear you. We can.
I can hear you. Okay, good.
Yeah, the camera is off though. It is pointing to the ceiling, I think.
Yeah. Huh? Yeah, it will probably come back. No worries. So
Sure.
I think it's just getting reset.
Sure.
All right. So I'll just keep talking. Okay. So the Act finally, when it came out in 2023, it was made in August 2023, and finally the organization itself is only about a year old. Early 2024, February 2024, the organization was formed. So this also has areas like missions to drive economic value chains and societal challenges and so on. So it has a bit of flavor of NSF and DARPA, right? So the simple thing I tell is it's a combination of an NSF type of mandate and DARPA kind of mandate. But it also has a lot of significant differences from the way National Science Foundation and DARPA run the US. I'm very familiar with it because I used to be a professor in the US and had grants from all these organizations. So it is set up also as an apex for research and innovation in India across all stakeholders, not just universities, as I mentioned earlier, but also to drive collaboration across universities, industry, labs, various foundations, CSR, diaspora, and so on, across all TRL's levels, but with a special emphasis on 1 to 7. Okay, so in terms of legal structure, it is not a department of the government, even though we are working, sort of using the machinery of DST. It is set up as an autonomous statutory body. A statutory body is something that is formed by Act of Parliament and is therefore called a foundation. So it has some of these special powers, and over time, we should see some of that also translate into more ease of doing business, which is some of the things I'm working on right now as I've taken charge. So we have several expectations here. So on one end of the spectrum, we have to raise the funding available as well as the effectiveness of that in universities. On the then the other side, we are also interested in catalyzing the growth of R&D investments, specifically research investments in India, and specifically catalyzing the growth of non-governmental research institutions in India. Right. So think of it very simply as more R&D labs or research labs in India. So I think this is a very important moment as we look at Viksit Bharat. That's the Honorable Prime Minister's view. And ANRF is meant to catalyze the human capital growth here. So if I were to simplify things, the most important thing that I'll be focused on is to drive collaboration across various things that have been traditionally silos, because problems don't respect silos. Problems are more interdisciplinary. Problems go across institutions who might need to solve it, or individuals, or even international for that matter. So the goal of ANRF is to look at funding problems that touch across the spectrum. Also partner with different parts of our government to help be the glue between these areas. So we will not be replicating what DST or DBT or any of the other departments, MIT and others fund. I know Secretary Krishnan had spoken earlier, but we'll be looking at interdisciplinary challenges that complement. We'll also be partnering with MIT in areas like semiconductors or AI or other sorts of areas that are necessary, but also with other parts of the government. Okay? So we'll be focused a lot more on interdisciplinary, interministerial type areas, and then in terms of depth and breadth, we want to take our top institutions and make them world beaters and help them become world beaters. And the breadth, meaning we want to increase the distribution of institutions doing high quality research. And our goal is to not just spread, the funding paper thin, but really to help drive merit in greater number of universities. Right? So another key goal is, economic theory says that, in the area of research and education and so on, we want to drive a lot of positive spillovers, and universities are one of the important aspects where a lot of human capital of the country is developed. So the more there is exchanges between various organizations, academia, industry, and various stakeholders here, we expect positive spillovers and workshops and organizations like MInT here also really help those positive spillovers, identification of new key problems, taking on bolder challenges. So because at the end of the day, our goal is that we want a very high-end human capital, which is going to drive the solutions of problems, as well as the networks and clusters and so on, ecosystems that are formed, which help do bigger things than just individuals and so on, right? So all of these are catalysts in the service of human capital, but individual human capital and network of human capital coming together to solve problems, right? So that's the mindset with which we are looking at investing here. And more specifically from ANRF's perspective, we have two approaches. I call the vertical and the horizontal. The horizontal, if I can take that first, is more classic National Science Foundation broad-based support at either a project level or a human capital level type funding. And also for small business and startups, we are also looking at new grants that we are working on right now, a grant program around deep tech innovation and so on, which is similar to the ignition grants that VIRAC puts out, or this SBI program that is being done by NSF. We'll be doing other bigger structures and more interesting structures as well. There is also, beyond the 4 to 6 type translation, beyond that, the 7 to 9 translation, there is a 1 lakh crore fund. The modalities of that are being determined at this point, which is going to try a completely new set of structures. And if you're interested more in that, look for RDI research innovation, right? So those sorts of funding will also be available over time. Okay. So we are going to be doing a lot more interdisciplinary things. We'll be doing both basic research as well as translation research, and various sorts of human capital, people mobility type programs, merit programs, and other sorts of partnerships with fellowship programs like the PMRF, and revisiting how to do postdocs, and also welcoming more talent back to India. A lot of our funding also goes towards infrastructure between DST and us. We are thinking hard about how to and make sure it's also shared between more institutions, whether those are bigger universities and aspiring universities, or whether they are deep tech startups, etc., right? Or the broader ecosystem of GCCs and so on. So there's a lot more that can be done there. So we want to use infrastructure a lot more efficiently. So finally, overall, if you look at the goals, we are interested in excellence in our top institutions, capacity building across aspiring institutions, and but with the aim of merit, with the aim of helping them drive towards excellence, and catalyzing research and innovation ecosystems. Right. So that's the broad strategic thought process with which we are driving it, and it's also a lot of hand wringing goes on in terms of the aggregate investment in India is 0.7% of GDP, which is correct, and the hand wringing is not off the mark. But at the same time, if you look at all the other countries which have higher share of GDP, the incremental share of investment does not come from government; it comes from the private sector. So one of the goals of ANRF is, as an incremental government investment, my goal is not just to put more and more government investment, but I have a challenge of inspiring or catalyzing. So I think the right way to think about NRF is to use and behave like a catalyst to crowd in a lot more non-governmental investment so that we can get to the right place where we have both aggregate higher levels of investment and better distribution of research investments that span the entire spectrum of basic research, applied research, and translation research. Right? So that's the thought process. And I was hired to take on this job because I have experience across all of these areas, and it's quite a privilege. And it's been quite a interesting time I've been spending here. There is a lot of excitement that we want to make a difference for the country. Okay. And one very key difference between how we operate and, say, National Science Foundation and others operate is, in addition to us making our own parliamentary commitments towards budgets, and then we allocate that capital out to our grantees, we also invite donor funding, partner funding from various sorts of entities. So if folks in the audience are connected to CSR or foundations or offices or families, please ask them to come and talk to me. So we are going to have a wide variety of ways in which you can participate. If you're a company, we are going to be having a lot more, sort of co-funded internship programs. Opportunities, so which allows companies at a lower level to also participate, but folks who are interested in a much higher level of participation, we have many other programs also. So for some of our flagship programs, we invite partners to contribute funds and also participate honestly in the program selection, governance, the entire life cycle of programs, whether those are horizontal or vertical missions that we choose to run. And we will run programs, deploy those funds and grants based on public interest. And these are called what are called the ANRF-led model. And over time, we'll be supporting a wide variety of grantees, tens of thousands of fellows and so on. Then another model we are currently experimenting with, I should emphasize this experiment subject to our board governance and approval on specific deal structures, is a model where we invest alongside other donors or partners, but we put a common minimum framework of IP, of selection, and so on. And the goal is to give some degree of protection to our grantees and some degree of fairness and in the public. We can inspire or allow large number of other funding to be deployed, and we will take the public money and use it for sort of public purposes that make sense in the public interest, right? So this is a sort of interesting set of models we are working on. So what I've not covered here are specific areas and so on, which are under discussion right now. We have an EV or an electric mobility mission program that we have recently launched, and some of the decisions are in the annual. But over time, in terms of areas like transportation and so on, I would urge you to be bold, and I am sure Secretary Krishnan must have told you something. I think we need to reimagine whether we are talking about urban living or rural living or logistics and so on and so forth. We need to reimagine, safety in our roads. We need to reimagine congestion in our cities, and and then and see what are the various things that we can do from a technology standpoint. Of course, there is government and state and central collaboration and various things, and of course just raw capacity that's being built in terms of all the metros in the cities or other sorts of things that are happening, right? So this is an exciting time for transportation. Transportation is the enabler of a lot of economics, and mobility is very important, and it's also a huge contributor to the greenhouse gas emissions. So the transition to sort of more cleaner forms of fuels and so on, and whether you're going towards electric and the source of that electricity comes from solar, or if you're going towards fuels and the part of that biofuels comes from ethanol, which in turn comes from biomass, which is in turn inspired by new enzymes that are driven by biomanufacturing, right? So there's a lot of exciting things that are going on, and these innovations could transform, both our rural and our urban lifestyles. Okay, with that, thank you and Jai Hind. I'm happy to take a few questions.
Thank you so much, Shiv. I think we've all been waiting to know more about ANRF, right? Since it was announced, it was great to hear from you. What are some of the plans?
On behalf of the MInT Collaborative, we are thankful that you have accepted our invitation and joined us online to give us this talk and for gracing us with your presence. Thank you.
Thank you very much, and I wish all of you very well, and good luck to the MInT community. Bye-bye.
Thank you, sir. A warm round of applause, please. All right. So an interesting event program last year was the 2024 hackathon conducted by the MInT Collaborative that was geared towards building solutions using digital technology to build solutions to neighborhood challenges, right from your parking woes at the society to maybe ambulance snags that you see on Indian roads. And for this hackathon, MInT had partnered with PALS, which is an IIT Alumni Association, and reached out to 40 different colleges around the 4 states of South India. And around 1,200 students from Tier 2, Tier 3, and particularly rural India, participated in this hackathon. And it was not just a hackathon, it was a transformative journey for the students because they were mentored and nurtured by the MInT Collaborative faculty and students into confidently presenting their solutions. I understand particularly the female students were nurtured and geared towards how they could come out and confidently present themselves on the stage. And it was very heartwarming to see the enthusiasm with which these budding technocrats came forward to present their solutions. Now, the winners of this of the hackathon was Team Tech Uniters, and the runner-up was Team Zone Guard. And we have both of them here today to present their winning solutions. So I invite Team Zone Guard first from Ishari Engineering College, followed by Team Tech Uniters from Sairam Group of Institutions to present their solutions. Can I have the students on stage? One is online, one is here to present. Can we have the screen, can it change? You're the team, right? You're second, right? Yeah. So we'll have Team Zone Guard on screen, which is from Ishari College of Engineering.
Hello, ma'am. I'm Monish KG from Zone Guard team. I hope my voice is audible so that I can present.
Yes, very clear. Please go ahead.
Sure. I will be presenting my screen right now. I hope my screen is getting visible. Is it?
Yes.
Yeah. Sure. So, hello everyone. Warm good evening to one and all present here. So I'm really excited to present our project here at the MInT Summit 2025. And first of all, I would like to thank our Ramki sir and Geeta Radhakrishnan sir from our MInT Collaborative for giving us an excellent and valuable opportunity to present here in a big platform such as IIT. So we are really excited to showcase our project. So our project team name is Zone Guard, and we are focusing on the problem statement automated traffic management near schools and hospitals. So our team includes myself, Monish KJ and Raki Krishna P. We are both from third year CAC AML from Ishwar Engineering College, Chennai. So this is the today's agenda of our presentation. Just So firstly, let us see about what's the problem statement that we are focused on. So urban traffic congestion. So it has become a critical issue impacting the entire movement of emergency and priority vehicles. And due to this issue of traffic congestion, the fixed times traffic signals add more problem to the issue of urban traffic congestion for the movement of particularly emergency vehicles. Though we could see, let's say, though the ambulance would cross even the signal if it's red, but it's not I don't we think it's not the right way to just like that cross the just like that the ambulance has to cross it way. Obviously has to cross the signal, but we have to make sure of the public safety as well. So we have few challenges over here displayed here that has happened recently that is concerning and related to our problem statement. Let's say in instance in December 2021, the ambulance in Chennai were frequently struck in the traffic near Arumbakam, and also in November 2020 as well, an ambulance was struck over 30 minutes on Purnamali High Road due to the roadblocks and so on. And also, the traffic near schools, particularly during the peak hours of the morning, there's a serious concern of traffic and so on. It also puts the students' health in concern. So we are also focusing to implement this project near the schools and hospitals both. So let's have a project overview. So basically we created a smart traffic management system that is focused on easing the congestion and streamlining the emergency vehicle flow using real-time analytics. So we have developed this system by integrating the YOLO V8 computer vision model. So that's where the ML role plays here. So direct the high priority vehicles such as ambulances for timely signal adjustments. So we also to enhance this further, we have also implemented dynamic control mechanism that also simulates how a traffic signal would change in the during the real-time simulation whenever an ambulance is being directed by our model. So on top of that, we have also developed a centralized dashboard where we can continuously monitor our emergency vehicles, and also we could also retrieve the counts of vehicles that are passing through the path, and also we have created an effective traffic control decision making as well. By looking at the dashboard, we can make some decisions of the traffic, controlling the traffic. So the implementation process. So this is the implementation process of project so far, how the project has been created from data collection to deployment. So the first process was to collect the data. So particularly we had to collect specifically on the Indian vehicle data sets, and also finding the data sets were quite critical issue, but we have overcome the issue, and we received a data set that contains the data set of images of ambulances for training our computer vision models. So the second phase was to develop the model. So by using the data set we have collected, we labeled it, then we had to train our YOLO V8 algorithm model on the annotated data set to recognize the critical vehicles such as ambulance. So the third phase was to develop the dashboard. So this, as well as I've already mentioned, we have created a centralized dashboard for real-time traffic monitoring. That is the front end of our project, where it can be also integrated in traffic control rooms for them to analyze the traffic. And the fourth part is the signal simulation part. So once we have completed our YOLO V8 for the YOLO V8 training model for detecting the ambulance vehicles, and we have integrated with the front end part of dashboard development, then we created a sample simulation of dynamic adaptive traffic signals that would actually simulate how the traffic signal color changes whenever an ambulance is detected. So, and the final process would be deployment of the project. So now over to Rakesh.
Am I audible?
Yes, you are.
Yes. Yeah, I am Rakesh Krishna P from Team Zone Guard. Now I will talk about the technologies that we have used in our project. So starting off with the backbone of our project, it's Python as a programming language. It's the main language that we have used for AI model development and the backend services, followed by YOLO V8, which is a computer vision algorithm that we have used to train our AI models. YOLO is nothing but you only look once. And we have used version 8 of that algorithm. It's a state-of-art object detection model developed by Ultralytics. In our case, it helps us to detect specific vehicles like ambulances, school buses, and others in real time. So, followed by PyTorch. PyTorch is a deep learning part that we have used to train our model. It is really a powerful framework for developing and training AI models. The flexibility that it offers are much more powerful than the TensorFlow, which is offered by Google. Followed by we have used to speed up the process. We have used CUDA, which is a GPU accelerator powered by NVIDIA. So using this, we can process our videos much more faster. For handling the image and video streams, we have used OpenCV. It is a go-to library when it comes to computer vision stacks, which are widely used in production. So for the graphical user interface and dashboard development, we have used Streamlit. This helped us to build a clean dashboard and interactive web app to visualize and project object detections in real time. So the next will be the demonstration of our project.
So now I will be playing a demo video for project dashboard.
So as you can see here, this is the software that we have developed for prioritizing ambulances. Here is an example use case in a traffic intersection. As you can see here, the ambulance is crossing and we have changed the traffic
I
lights
hope the video
dynamically.
is playing.
Yes, yes, it
I hope the
it's
video
playing.
is playing.
Yes.
Okay, thank you.
Yeah, so you can see here that when the ambulance is detected, the traffic light has dynamically changed, and the car and van over that are approaching over the top and down side has stopped based on the dynamic traffic light adaptation. So this is the solution that we have come up with. So to conclude our project, our smart traffic management system that is powered by AI, AI will reduce the traffic congestion, especially when it comes to emergency and school vehicles, which cannot afford delays. What we have built is an AI-powered solution that can detect vehicles in real time and adjust traffic signals dynamically by prioritizing them. Now, while the system is currently running in a simulated environment, it's already delivering the promising results that we have presented in the previous MInT conclave. The integration of YOLO V8 algorithm has much more smoothened our process. Of course, there is a lot of developments that can be done in the future when we move it to the production, like integrating it in the hardware, like sensors, and of course, we can test in a real-time environment. Thank you.
Thank you, Zone Guard. I invite the next team, Tech Uniters, to come on stage.
By the way, thank you for giving us the opportunity to present our project. Thank you.
You're welcome.
Greetings everyone. Myself Selva and this is my team, Sriram, Yukesh, Balasubramanian, and we are here to present our project, ParkSync, a real-time inventory. Next slide please. A real-time inventory on cars and bikes. In India, the exponential growth in the number of vehicles has created a need for number of parking spots available, leading to various challenges. The improper parking made in the streets and the roads has caused increased fuel usage, which means increasing the carbon footprint too, and also the vehicles which are in the round for searching the parking spots. To solve this, next slide. We have come up with our idea, our project vision. What we are really trying to do here is to improve the existing parking infrastructure with a better space utilization and a streamlined process for the Indian conditions, especially cost effective, and to mount this system to be in a scalable way and also in a cost effective manner. The existing system is using the sensor based setups. As a part of the MInT collaborative, we gone to the ground research for AeroHub to see and to survey about the existing sensor system in the AeroHub, and we got some inputs there. And at third, reducing the carbon footprint. As I already mentioned, the fuel emission from the vehicles, which are in the two ways. Like when a car is when a user is searching for the parking spot, when the spaces are not available, and the improper parking that has been caused the traffic congestion, and the traffic congestion, the vehicles are standing, and the fuel usage is increasing. Indirect impact on that. Next slide. And here we can see the architecture, and in the left side, this is the flow of work. Let's start with the user application, the ParkSync application. User can book can do the basic operations like booking, reservation, and the managing the bookings also. Using the data that is from the individual parking lots, the system vehicle occupancy model detection system. There, an IoT edge device is installed up there. Using the YOLO version 8 custom trained ML model, our system implements the detection of vehicles there. And here the ANPR validation model. You can see we are familiar with the ANPR validation system. This is integrated here not for only the verification purpose, but also for a payment processing step 2. And also, like in the parking lot control system, this every ANPR system and the vehicle occupancy detection constitutes to the parking control system. Next slide. Sorry, the previous slide, please. And in the right side, you can see a sample layout of the parking lot of a parking lot. And here, there is no need to be one camera, as it depends on the area. For the required area, there may be several cameras to cover all the field of view, to cover all the parking spots in simple. And it constitutes both car parkings and vehicle, that is four-wheeler vehicles and two-wheeler vehicles. Here the concept for four-wheeler vehicles is same as individual vehicles are detected. And for a two-wheeler vehicles, a concept of zone is introduced here. Like if a zone A has a capacity of 8 vehicles, that is 8 two-wheelers, if the zone A is completed, the 8 capacity is breached, the zone 2 will be started to fill. This is managed through the reservation engine in the mobile application. Next slide, thank you. Our project work summary. What we have done till now. The vehicle occupancy reduction model. As I already said, it utilizes the live CCTV footage from the parking lot for real-time occupancy reduction. We have come up with this idea only for not to eliminate the sensor-based system as a primary goal, because both, as we seen in the AeroHub, they utilize both a sensor-based system and the surveillance system. Here we can eliminate the sensor-based system, and we can use both benefits in the surveillance system too. And second, ANPR validation model. As I already said, it is for verification purpose of the particular specific time period to validate whether the vehicle has been registered on the ParkSync mobile application and for an extra usage too. it triggers a payment processing. Let's take an example here, instance. A user A reserves the parking slot from 9:30 to 10:30. He or she enters the parking lot, and the ANPR validation system allows them to enter, and they have parked in their parking slot. After the time is reached, he or she has not been come here yet because of several reasons. It may be a shopping or anything else. Because of that, the time period given to the particular parking spot has been breached, and to manage this here, the extension fees is charged. A certain amount is charged to extend the parking slot. And to as this first 1 hour, which is reserved in the application, prepayment is done for the first period, that is 1 hour or 2 hours the users required. And the remaining amount is collected while the users are exiting from the parking lot at the ANPR validation system. It's an exit control too. In the ANPR validation system, as soon as the vehicle leaves through the exit, the ANPR system validates it and checks for any outstanding amount on the vehicle number. If there is any, it triggers a payment notification to the application, and it completes, as soon as the user completes the outstanding fee, clears the outstanding fee, it is allowed to pass through. And the in-lot spot guidance system. To provide users a seamless experience, we have integrated a in-lot parking lot navigation. Usually, the user can be navigated from his location to the parking lot which he has booked. And to navigate internally, that is this slot or this slot, slot 1 or slot 2, an internal parking lot navigation system is installed here. Next slide, please. And a fourth, adaptive pricing logic. To maximize revenues and to handle the peak hours in the city, dynamic pricing factors are made up here. The parameters we have followed here are a weather condition and the traffic congestion level, high, mid, low, based on the traffic congestion level. Traffic congestion level around the particular parking lot, and the demand supply ratio. The demand supply ratio here is the number of parking spots available in that particular area versus the number of users requesting for the parking spots in that particular area is calculated here, and this can be benefited for maximizing revenue models. And a demand multiplier, by taking all the factors, a demand multiplier is calculated here, and the demand multiplier is added to the final base fare. The price changes for 2-wheelers and 4-wheelers, the amount is calculated and final payment is done, the prepayment is done by the user. Reservation engine. A reservation engine, as usual, it has the basic functionalities: booking, reserving, managing the bookings. Here we have the extension capacity. As I already said, the extension capacity is automatic here, but it has an extra charges because the user has been privileged to extend the time limit. But here we have an extension feature, a voluntary feature. If a user thinks he or she is gonna breach the time limit, he can extend the time before 15 minutes or 50 to 20 minutes. A time frame is given to them to increase it. And efficient slot management can be done like reallocation algorithm. The reallocation algorithm I would like to explain by using an example. First, user A comes here and books for 5:30 to 6:30, and a user B books 7 o'clock to 8. The user A extends his time, either voluntarily or by using the automatic functionality here. The second user's schedule, that is on the same parking spot, is also here, which is conflicting his booking system. Here, so we have, as a holistic system, it has to reallocate the second user to a different parking spot in the same parking lot too. So the system handles this reallocation algorithm in a seamless way too. Next slide, please. Let's see a project working demo.
We have completed the prototype of our solution, and here is the working demo of our solution. Video, please. The user starts with the login, and the application detects the user's location, and based on the user location, it suggests the nearest parking spots. And in the left-hand side, you can see Sairam parking, and the availability count will be updated in real time within our application. So the functionality works seamlessly for our across all the parking lot integrated in our system. So we have also done it for bikes based on zone-based divisions. So the user can reserve a parking spot by providing the details such as vehicle number and decide time period and proceed with the payment. And once the payment is completed, the booking is to be confirmed. And the slot number will be revealed just 15 minutes before the booking of the slot time. And our app also supports navigation to the lot and also to the spot. And the user is also allowed to extend their booking just before 20 minutes of their booking end time. And the extension can be done of 30 minutes, and the extension cost will be slightly higher than the ordinary bookings. So in our parking lot, we also integrated ANPR system. So in the ANPR system, the system scans the vehicle number and allows the vehicle let into the parking lot only if the vehicle number has been booked for the specific time period. So this is the prototype we had done, and the vehicle occupancy model is running on the edge computing device, which will be updated in our database and which will be reflected in the website. So this system is tested under Sairam Techno Incubation Center.
Thank you. Thank you for the opportunity.
Yeah, I just want to say a word. Okay. I am really heartwarmed with the work done by these teams. Okay, both of them have demonstrated such a high level of technical capability, ability to learn, implement, and actually take an idea and make it something that it's almost ready for use, right? So I really want to appreciate not only the teams for their hard work, but all the mentors. I think they are in the audience somewhere for guiding them. So I appreciate this. I can almost see some of these becoming small digital public infrastructure that goes into the stack. Can you imagine that this being used across many different cities and locations, right? So thank you very much.
Thank you.
Okay.
Thank you, Team ZoneGuard and Tech Uniters. We are so glad that the hackathon has sparked some bright ideas. And we are also, on behalf of MInT, thankful that you have presented your solutions here at the summit today. So on behalf of MInT, we have a small memento to thank you as a token of appreciation. And I invite Ms. Gayatri to present the memento.
So for people who don't know Gayatri, she's been the force behind getting all these people to think, learn, and act, right? So thank you, Gayatri.
Center. Thank you. So I'm back to my open book test question. What is, now even the French benchers could answer. What is the theme of today's summit? Not bad, all your eyes are at the right place. So why AI in mobility? Is it a fad, buzzword, necessity? Any thoughts? Any thoughts? Necessity, okay. Then? Anything else? Make it more advanced, okay. What else? Data-driven solutions, okay. Is it all or is there much more? So to know this, we are coming to the most anticipated and eagerly awaited moment of the summit, which is the theme reveal. So we have an tete-a-tete to let you know why AI in mobility and what it stands for. And for this, I invite, first I'm inviting the moderators of the panel, who is Professor Geeta Krishnan and Dr. Ajay from Bedrock Robotics, co-founder, vice president, and MInT co-team member. Professor Geeta Krishnan, you already know, the driving force behind the MInT Collaborative. And joining us online are the experts, Professor Travis Waller, Chair of Transport Modeling and Simulation, TU Dresden, and Professor Srini Parthasarathy, Department of Computer Science and Engineering, Department of Biomedical Informatics, the Ohio State University, and Vajra. Over to you, Professor.
Yeah, so can we have Ajay also on the screen here, and Professor Travis? Okay, I think what we'll do is first, we actually asked students, researchers, right, the common community to tell us what they felt, right, is the role of AI in mobility. So we have a short video that we've compiled. What I request is, Rahul, if you could play the video of what different people have said, right, about AI in mobility. We'll listen to that and then we will enter into the conversation.
Hello everyone. There will come a time where mobility just won't mean movement. It will mean awareness, an intelligent system that integrates how we are feeling, how you drive, and how the road reacts, making your every ride better. Every ride becomes a data point, and every citizen becomes a sensor for government to make smarter decisions. Accidents will drop because recklessness will be caught in real time. It's no fiction. It's Yatra AI, and it's just a matter of time.
AI can redefine mobility from one-size-fits-all to personalized adaptive solutions. Most existing apps are commercially driven. I propose a community-powered, person-centric mobility AI platform where individuals in a specific zone can share a vehicle based on trust, routine, and fair cost-sharing model. This can enhance private vehicle utilization and reduce traffic congestion.
For me, AI in mobility means is to help me in making decision about travel. So let it be about driving or like maneuvering through the traffic or moving across that city. So it should be help me in making the decisions for me.
Okay, my name is Ropam Verme. So when I think about AI in mobility, the first thing that comes to my mind is self-driving cars. These AIs can drive much safer than us, given the lower reaction time. And also they will be much more disciplined than us without breaking any traffic rule. And also when it comes to blind spots, they can do a much better job than us because they can rely on data collected from different sensors and come to a better decision for avoiding any kind of accidents.
Everyone, Namaste. So AI is transforming mobility fast from predictive traffic systems to autonomous vehicles. I have seen firsthand how intelligent tech is making transport smarter, safer, and more efficient. Whether optimizing routes or reducing emission, AI is the driver behind the future of movement. And this is just the beginning. Bye.
In many ways, like improving traffic management. For example, AI can be used for tracking real-time data from the sensors, cameras, and GPS. And AI can be also used for reducing traffic accidents count, improving road safety, and make more accessible for people with disabilities for their needs.
Hi, I am Anish Fatima. A in mobility. So I faced one issue in traffic signal. I think many people face this issue, I guess. So I was waiting in a traffic signal. In my approach, it was very long queue, but we got red for long time. The other two approach, there is no vehicle, but they got green for long time. It is a AI-based controller, means it will detect which approaches have more number of vehicle. We give a priority for that first particular approach. Which approach have very less number of vehicle, we give least priority. So it will be very helpful in AI. Thank you so much.
So the idea is to generate route for a particular destination based on the mood of an individual. Suppose I want to visit to places which has more number of markets or food stalls or restaurants, or even I want to view more scenic views. So generate the route like for the combination of the preference according to the user.
When I think of artificial intelligence in mobility, I think of systems which are capable enough to process large-scale data sets and come up with useful insights, information for general public who wish to use different set of different available modes in messaging.
So today we are going to talk about how AI can be integrated in mobility. So AI is a combination of ML, deep learning, and data science. So ML can handle a single dimension at a time. Let's say a classification of vehicles, and if it's like we can integrate so many ML models into under the same umbrella of like detecting vehicles and synchronizing the traffic signals. It makes us we can identify or calculate the amount of vehicles approaching the signal, and it is used to increase or decrease the signal timings. So in this way, it helps in optimization of mobility.
AI-powered traffic management system is like a smart brain for our roads, our transport systems, which collect the historical data and optimize our traffic signal so that the traffic delay will be minimized. In the other perspective, AI can be used to optimize our route so that we can get the safest and best routes, which will also minimize the delay for the transportation users.
Okay, so I think those are some, examples that people had, right, on what they think AI's role will be in mobility, how it can affect mobility, right? I think Ajay is also online. If we can have Ajay also on Spotlight. Yeah, welcome Ajay. Welcome Travis, and I think Srini is yet to join, so maybe we'll get started, and Srini, as he joins, we will keep the hard questions for him, right? So Ajay, I think you wanted to get started. Yeah, go ahead.
Yeah, maybe having heard all the students propose so many different ideas, right? So, but where I wanted to start with was, you have seen this technology evolve over the last many years. So maybe we start with an example where you saw the AI used and was an aha moment that was transformative or had a big impact, right? Or the other way as well. So maybe you have an example of the other side as well. We thought that it would be very impactful, but it ended up being okay, maybe it's not that much better than classical methods, right? So maybe we start with that, Professor Waller.
Sure. No, thank you. And thank you for the invitation. It's wonderful being here and seeing. I saw a couple of the presentations and then the videos, and they're excellent. Seeing this passion and these creative ideas, I think it really highlights the different technological streams that have been evolving for so many years now at a state where creative individuals can interweave them for really applications that in previous years were just unthinkable. So lots to touch on there, but I'm sure we will through the discussion. In terms of kind of aha moments and challenges, one aha moment in our world, I'm kind of a network modeler. I do logistics and optimization, but primarily I look at planning models, and we've been building them for decades. Dynamic traffic models, but both static, dynamic. And we developed a machine learning method over the past almost 20 years, if you really dissect it, where we can rapidly build a regional, city, or even sometimes nationwide aggregate network model of travel patterns. And historically, these were really intensive things. You would have to do household surveys. It'd be months and months and months, maybe a year. We developed a method that backcasts travel demand using things like Google, TomTom, other emerging data sets, as many other researchers, OpenStreetMaps, but so we can more or less automatically create the model. We could do it very quickly now, instead of months, maybe hours. And it's an unfortunate application, but it was an aha moment when the Ukraine conflict broke out in February 2022. We had the realization this method would work. We were still getting travel times, we were still getting data, and we modeled Ukrainian cities, and we created a travel model every day, day after day, for months throughout the conflict, which allowed us, we believe, for the first time in history, to quantify travel behavior during a human conflict as it was evolving. Because historically, it would be unethical for other methods, and the methods worked. We've published it a few times. We're using it for other projects. And now we've been looking at disasters, and that was really a key moment that these methods have matured to the point where you can use them for proper planning analysis and for applications that previously were just not possible. In terms of a continuing challenge, we look, as many others do, lots of applications for LLMs. They're still not quite to the point where if you ask it questions, they'll sort of give you mainstream answers based on things you more or less could Google. In terms of understanding the modelings and interpreting hypotheticals, they're not yet to that point. I definitely am not one in the mindset who would say they'll never be at that point. But I think at the moment, that's still a research frontier, is how to get the LLMs at a point where they can maybe interact with the models and give more informed, structured guidance being informed by them. So how we get LLMs integrated with other more structural modeling, I think, remains a frontier that needs to be addressed.
Great. I think so. I had a question, right, about maybe for the last 70, 80 years, transportation has focused on infrastructure, right? We talk about either infrastructure development or we talk about automobiles, right? And of course, we have a center here that looks at software-defined vehicles and so on. Now, a lot of mobility is about soft technology, right? And AI is also a soft technology, right? So do you see this hardcore, if I can call it, mobility transport industry, how well will it receive, right, the soft technology of AI and adopt it? Do you see that happening? Do you see that there is resistance in this industry? What do you think would be the path forward? How will the hardcore industry adopt the soft core of AI?
Well, I think and mobility definitely being because there is so much sort of already in place. We're all living with these systems. You always have resistance to any innovation and disruption, but eventually the market will determine the outcomes. And I think AI increases your efficiency and capability so much that it will be that winner over time. And it will be, there are definite big pitfalls, but there are also massive upsides. And really what it does is it shifts the technology landscape. Just as one example, in a broader technological sense, it's not necessarily that it's fundamentally new mobility ideas. There are certain ideas that are very old. Just as an analogy, car share. To my knowledge, the first car share initiative was in Zurich, Switzerland, I think in the late 40s, 1948, I think. And it didn't work. It was a great idea, it just didn't work. And the reason it didn't work was quite simple. We hadn't invented the smartphone yet and the internet. Once we had the smartphone and internet, that good idea suddenly, it took over about 50 years, but once that was there, that good idea that many people derided as silly was obvious, and now we have Uber, and everything's changing for mobility as a service. But what really changed wasn't the idea, it was the technology to enable the idea to happen. And even in the presentations that we've seen here, there's a big theme of being able to look at this system at higher and higher levels of spatial and temporal fidelity. When I was younger, as many of us were, thinking of trying to even observe individual parking spots and bicycles would be thought of as silly. But now that technology gets there, if you blend it in the right way, you can do this, and it opens up. Basically, it gives us the tools that put the ideas that have always been good into practice.
I think that's a great way to look at it, right? And I didn't know about the Zurich, startup way back in the 1940s. So Another question that I think about is telecommuting is something that's been around for some time, right? And it had a very direct kind of impact, right, on mobility, right? Fewer people traveling, and of course, COVID kind of amplified that a lot more, right? And there have been other multiple effects of digital technology on mobility itself, right? Will AI have a much larger impact than anything we have invented till now, right? Maybe barring the wheel, that's way, way back, right? Do you think AI is really going to be the technology that completely redefines mobility, right? What is your take on that, if I may?
No, I think very possibly, because AI enables just another step change, order of magnitude greater rapid change, potentially instantaneous decisions. I mean, real mobility planning, management, delivery are still really actually slow processes. And AI can help cut through that and deliver very, very rapidly quick change. But that opens up potential pitfalls as well, in addition to the upside of rapid change. We tend in our research to refer that's related to what we call the concept of mobility as a resource, which we view as an evolution of mobility as a service. Within mobility as a resource, we dissolve a complex mobility system down to its smallest atomic parts and then reorganize it in real time to better match the supply of mobility with the demand for it. And we assert that such approaches are inevitable and will become common. And to put another way, and from the presentations and the things people were saying in the video, which I completely agree with and were very insightful, at a high level, it's multiple streams coming online. In addition to sort of AI and so we have now the potential for highly personalized solutions down to the individual. We have extreme high fidelity and observation, which historically was unimaginable. The processing now of massive volumes in data, and then this complex real-time decision-making, which to really benefit from those other things, you need that real-time complex decision-making. Now, the potential pitfall of that comes down to ethics and social values and being able to encode those things into the algorithms. And if we don't, that is a massive potential pitfall. But given that we can navigate that hand in hand with the technology, that ability for complex real-time decision-making really just opens up, it unleashes the potential of all of those other technologies. So it is the thing on top that integrates and synthesizes all of this stuff that has been happening.
Thanks, Travis. And Srini also joins us. Hi, Srini. Thank you for joining in. And so we just got started, a few minutes back, and I've been, asking a couple of questions to Travis, but maybe if it's all right, can I have a couple of questions with you now, Srini?
Sure, go ahead.
Yeah.
And apologize for the delay. I was having some technical difficulties at my end, so finally got that sorted out. I'm working off my cell phone right now, so we're down internet here. So
okay.
So okay.
But I hope it's not some disaster or something that it's just
no,
a normal outage.
I think it's just our unit. They're working on something here.
Okay. So, yeah, I think we are able to hear you clear and also see you, right? Of course, Srini is our distinguished, professor in the Vadvani School of AI, right? And he's considered an expert in AI. And the interesting thing is Srini also has been working on applications in mobility, right? So I thought it'll be very apt to hear from him, on his thoughts there, right? So Srini, I'm going to ask you about, this hype around AI, right? So I think already Ajay had asked, Travis about, some aha moments in AI and mobility, right? So what according to you, is going to be the true impact that AI will have on mobility? Or is it a lot of hype and the impact is perhaps further drawn out? What are your thoughts around that?
So I'm going to turn that question around a little bit and, sort of take us through a very, basic sort of history lesson, if you will. AI and mobility have been kind of joined at the hip for quite a while, if you think about it, if you really think about it. I mean, if you think about autopilots, especially if you think about autopilots in airplanes, they've been around for more than a century. I think it was, early 1900s when the Sperry Corporation came up with, the gyroscope-based autopilots, which was taking information from data that was being collected. It was mechanical, more than computation-based back then. But eventually, computation came up. And in fact, it was the same organization that sort of built some of the first mainframe computers and things like that. And then sort of, I think there was this, I think they were called Sperry Rand for some time. And then, if you think about the UNIVAC computers that came out, and some of those ideas have sort of been integrated into the mobility industry, especially into the, aircraft design. And today, for example, when you think about aircraft design, there is a lot of AI-based approaches that are already being integrated. So, but one thing that industry has done well, the airline industry in particular, if you think about it, is they are very careful by and large, with the exception of, these disasters that we all hear about and read about from time to time. If you look at overall safety records in airlines, I think it is just incredible how much they have reduced, the number of accidents or issues or technical difficulties because they're using sort of AI for weather forecasting, figuring out whether where the airline should be flying at, what height it should be flying at, how to, there's something coming up. So there's a lot of AI that goes in to helping the pilots, and aside from autopilots, which have been around in some form or the other since 1912. The other thing is, I mean, not just in the airline industry, but you are seeing, when was the first automated car? It was somewhere in Germany, I think, late 80s, early 90s, where they ran the first test for, I don't know, something like 90 miles of driving automatically or something like that. But this was in a test setting. It was not in the real world. And car companies, Tesla, Lucid, and others are taking their time to sort of get this out in a safe way. Now, the real challenge for us is, if you think about AI today, we think about chatbots and things like that, which can be useful for helping the user experience. And a lot of that is being integrated into the modern infotainment systems that cars and things are using. But one of the things is a lot of these technologies are coming out too fast and too furious. We really need to take a step back and make sure that their deployment is safe. And I think the overriding thing is safe deployment. I think, I use the example of airlines, but one thing to keep in mind is that airline travel, at least, 50 years ago, was primarily accessible to the relatively well-to-do. AI today is accessible to everybody. And the kinds of AI that Travis was just talking about is accessible to everybody. So given that the access is easier and the advancements in AI are rapid, we do need to take a step back and check, I think safety is the overriding issue that we need to worry about in these kind of deployments. So that's, sorry if it was a bit long-winded, Geeta, but that's sort of my
I think, I mean, I never thought about all the autopilots as AI systems, right? I think, right? So that's something that's been there for a long, long time, right? Ajay, you had something to ask?
Yeah, well, I mean, I was going to actually just make a comment because I was resonating when Professor Patsadi was talking. My son is a pilot and he didn't want to drive, but he learned flying before he could drive. So he felt like there were smarter people and that was much safer to do that. So it resonates like how when you deploy these things and you look at like all of the elements that have to go into it for safe deployment is super critical. And having worked at Waymo, I kind of found the same what do I say? Same criteria on like deploying something, right? Safety is the highest bar. It's pretty challenging with AI. Like proving out that it's safe is even harder. So I guess like coming back to my question, I was actually going to ask you a question about more a longer term, like where you saw these large LLMs going. But then like it occurred to me that one thing that is probably quite relevant to all the students who are sitting there, as well as to the institute itself. Maybe it's a more controversial question, like should all students stop learning like classical modeling techniques and like actually focus on like only AI based techniques? Or like how do you balance like these two worlds? Or if AI is going to do everything, maybe students should do something else. Right. So I thought like that should be a good discussion point for this group.
Who wants to go first? Travis, Srini, you want to?
Yeah, I'll give a short answer and then maybe elaborate on further if necessary. I think Ajay, at least in my mind, is not a controversial question. I have a clean answer here. I think these technologies exist, so use them wisely, use them responsibly. I mean, but are they going to replace first order, first principles modeling, at least for the kinds of AI we use for aircraft and engine modeling and things like that? Absolutely not. I mean, they're not going to replace it anytime soon. So I'm not worried about, if you think about, pinpoint accuracy with some of these sort of traditional physics-based models, or for example, in another discipline, I don't see that immediately replacing, those methods. They're not as good in terms of accuracy, in terms of other attributes we care about. However, they can speed things up in terms of how quickly we can get to the solutions. So absolutely, we can use them, but we have to use them responsibly. I mean, I'm teaching a class right now on network science, and it's a split class. The first part of the class was didactic, the second part is Socratic. But when I'm asking them to present work, I'm also asking them to evaluate how well, if they fed that work into something like Notebook LM, how well it does. So I'm asking them to criticize how well this current generative technology is working. And what they're finding through that process is, rather than using it blindly, if they use it responsibly, it can be more useful to them in their learning process. So I'll stop there and hand it over to Travis.
Yeah, I could not agree more strongly. And also I'm honored. So actually my undergrad degree was from the Ohio State University about 30 years ago, bachelor's in electrical engineering. And the story I've told many times, and this even before the rise of AI, this stuck in my head. I had multiple semesters, multiple quarters there of electromagnetics. So one of the more difficult classes I've ever taken, antenna design and all of that stuff. And the professor was excellent. I may not have appreciated him as much back then as I should have. Quite older fella, brilliant in the area. But I will always remember multiple times through every class I had with him, he would just go on a rant that he was furious that the department head and the dean have directly forbidden him from requiring that we learn electromagnetics with a slide rule. And in his assessment, we would never get a deeper understanding. We would never properly learn the topic unless we were learning it with a slide rule. And I use that analogy a little bit with AI. I think the tools change. We have to change the method of education. We have to change the questions we ask and the way that we do it. But we need to be learning these topics with the latest tools. But it does change the way we learn and the way we teach. And I think that's what we're struggling with now, is how do we really leverage the full power of these new emerging tools and the educational paradigms that we use around them. I think that's the challenge we face. But I agree completely. In terms of first principles, and this highlights the limitation we've observed in our research that I mentioned a few moments ago, there is a structural component. And especially if you're dealing with hypothetical situations where in ecosystems and system designs that have never existed before, and you're envisioning how they might work, you do need those elements of structural modeling and causal relationships to come into play. And how we blend those appropriately, I think almost every educator in the world right now, we're dealing with how to do that in the best way.
Great. I think really deep thoughts there, right? And the importance of merging classical thought process with perhaps AI, I think resonates from both the experts. Maybe what we'll do is now we'll open it up for some questions, comments from the audience, both online as well as over here. And then maybe we'll round it out with a final question that Ajay has in particular to both of you, right? Any questions, comments from audience here or online? Yeah. Oh. Ramki?
I'm not sure whom to address this. This is Ramki from MInT. So maybe this is to Professor Pathasarthi, right? So in the world of mobility, there's a lot of decisions required, decision-making required, especially when you think about digital mobility and digital kind of public infrastructure to enable better mobility solutions. So whether it be learning about the data or whether it is about decision-making, where do you think we should actually focus the use of AI in building out our digital public infrastructure?
So, and I think, I mean, that's a great question. I can tell you where, at least from looking at some recent surveys done by McKinsey or Boston Consulting and Olivia Women, all of these surveys say that, or suggest that, at least entrepreneurially, the focus in the use of AI in mobility has focused primarily in two sort of areas. One is, as I said, inside the car, the experience, the user experience, the infotainment, the way in which the infrastructure is designed. And of course, the other is, the emphasis is on autonomous efforts. So Tesla, Lucid, and things like that. So that's where at least the focus has been. I think the overriding or overarching thing I care about personally, and this is more of a personal sort of perspective than anything else, is whatever you do, you have to do it safely and you have to test it for a period of time. There has to be longer runways than, to use an analogy. There has to be longer runways before deployment. I think right now what the problem we're seeing with some of these technologies being released way too rapidly is we have not had, we meaning collectively, we've not had a chance to understand how they might work. I think Travis talked about, potentially unseen environments, or at least in the AI community, one of the hot topics is out of distribution learning and things like that. So if you see something, or if the autonomous bot sees something that it has not seen before, then how will it react in that circumstance? And that's where some of these accidents and some of these events where these autonomous things went down are something that we need to think about. The other thing, and right now the state of California is actually, it's going through the legal process. The other thing that we need to think about, I think, very carefully for those in policy, is how are we regulating this technology? And that may help sort of, put in place some of these runways and things like that that allow us to truly and carefully test some of these technologies before they're deployed to the wild. As I said, the big change between, even now, if you think about, pilots, and I think Ajay said his son is a pilot, the amount of training that his son must have gone through before he was allowed to fly, and that too, many times you only have a license for a certain type of plane. You don't have, you can't just jump into any car or any plane and then start flying it. I mean, maybe you can, but you're certainly not legally allowed to do that. And so I think the amount of training they go into before they use that is significant. And clearly when we go buy a Tesla, kind of off the shelf or whatever, you don't have any more training than the next person who's driving a car. So it's accessibility in this domain is something that it is what it is. We have to work with it. So we have to make sure that the safety elements are carefully taken into account. So I think AI safety is perhaps, at least in the mobility space, has to be one of the most important elements, to answer your question. Yeah.
Travis?
I completely agree with that, because I tend to be a bit more on the planning side than on the control automation side. It's basically the analog, whereas they're very concerned about safety. I'm very concerned about ethics and fairness, and in terms of the real-time decision making that's being made, how to encode our social values into these algorithms, and that's a massively wicked problem. But it needs to proceed hand in hand with the technology. But that's very delicate work. Whose definition of fairness? How can you appropriately deal with that across a society? But that's absolutely necessary work that has to be hand in hand with the social sciences, even humanities, that has to proceed. And similar, that has a similar implication on these runways, to use the same analogy as Srini, which was an excellent one, is we have to find ways of institutions and procedures to make this co-development proceed appropriately. But it's absolutely vital, if we're to live in a world increasingly run by algorithm, that those algorithms reflect our society-wide perspectives.
I think once again, fairly deep thoughts. I think Rama online has a question. Rama?
Hey, can you hear me?
Yes.
Yes. Hey, Travis, good to see you again.
Hey,
Hello,
Robin, good
to meet you. Yeah. I wanted to bring a slightly different perspective here. So when we talk about AI, it definitely depends on a lot of data, right? And that means it is conditional on the type of data that you're able to sense and feed into it. And for the most part, the type of data that is becoming available to us nowadays is mostly on the supply side. You have a lot of measurements of what's going on the roadways and so on. Very little on the demand side, in sense that you don't know who's in the car, why they're traveling, what their demographics are, what is the situation in their home that is causing them to make certain decisions that put them in the car in that point in time, and so on, right? And that has always been the traditional focus of our classic type of planning models and so on, where you conduct detailed surveys, you get a very detailed picture of what the household structure looks like, how people make decisions, and so on. So from a point of view of a technology that's very nascent, that is coming into the field right now, what are your perspectives on where this needs to go, so that even if you're trying to build models that are trying to predict what the future of AI deployment might look like, you need to know how people are viewing this, how they're adopting this, why they're adopting this, and how they intend to use it, right? And as the technology is evolving, you need that picture, which we're not getting right now. So some quick thoughts from both of your perspectives would be interesting.
Travis, do you want to go ahead? I'm happy to chime in.
I can take. I'll kick it off. Completely agree with your observation, Rama. I think we're observing the exact same thing, and you're very right that it tends to be a supply side, and it's not just the amount of data; it's the universality. Like, if there are certain data sources now we can get about the network that are effectively global, There are some sources of more behavioral or demand data, but they differ a lot region to region, and there's huge gaps, and often you can't get it at all, but you can get it some. I think at least the current thinking for us and many of those I interact with is because some of these, because there is such power in it, there are certain inevitabilities about just doing it, and then to the extent possible trying to backcast information on the demand. So trying to infer it, that if you observe the network long enough, you might be able to come up with some sort of estimations on that demand. And there may be confidence intervals or other statistical things that you could say, but they're much more aggregate than what we could get through rich surveys and behavioral data. But you can at least backcast them somewhat. And then to augment this perspective based on those pockets where you do have richer behavioral data. So try to learn statistical proxies from the network side, backcasting into demand, training based on those pockets of richer data, and then using the trained models more globally based only on network data. At least that's the current thinking. Now, into the future, through apps or other sources, if we get more standardized demand data, that would be far greater. But for the time being, effectively, it comes down to trying to backcast the demand.
Yeah, hindcast the demand. Yeah, no, I couldn't. I tend to, agree with Travis wholeheartedly on this. I can also speak a little bit to a couple of personal research aspects that may shed some light on some of this. I think Rama, the challenge, at least if we're talking about mobility of vehicles, vehicular mobility, not airlines, and I think airlines have figured this out pretty well by and large. So I think sticking to sort of day-to-day traffic conditions and monitoring and things like that, most urban cities do have a reasonable sense of the demands on their infrastructure on a day-to-day basis. Where sort of things kind of go awry is when an unusual circumstance hits. So a disaster strikes, there's flooding, transportation infrastructure is down, power infrastructure is down, and they're all interconnected, and those are the cases where it's very, very hard to plan for, as Travis would call it. And that's an area that we've been spending a lot of time thinking about, at least in my group. What happens to the transportation sector when you need to absolutely get people to the hospital, who are dealing with some critical issues, and the roadways are blocked and things like that. I think for day-to-day, I think there is a fair sort of estimate of demand that you can take into account. So essentially, there are pretty good, traffic forecasts that will tell you, you should not be driving on this highway during this period because you're going to be back to back and jammed. And so if you can avoid it, avoid it. If you can't avoid it, well, you're stuck in the traffic jam, so to speak. And this happens at least even in almost every city in the world, every major city in the world, you have reasonable good on that. Now, where things become a little more challenging is the kind of behavioral, why is the person in the car? Are they commuting to work? Are they commuting, dropping their kids off at school and things like that? So that part of the question, I think, I'd be a little careful about that because I feel that does infringe on privacy, and privacy laws are, they're pretty stringent in the US. They're less stringent, let's say, in Singapore, to give another place I've lived at, in some respects. And so it depends on the law or the regulation of the land, but I definitely know that there is interest in, for example, in multi-driver households for figuring out who exactly is driving the car so that insurance companies can figure out the appropriate premium. So this is, might sound trivial, but relatively speaking on the use of AI, but AI is being used to figure out, which of the 3 or 4 drivers in the household is actually driving the car, and then, getting percentages of how often they drive that car and using that to come up with the premium. And, insurance companies in the US are already using these kinds of ideas. And so, at some level it's acceptable, but at some level one has to also worry about data privacy. Oh, and one big challenge here with the car, modern car, I think Oliver Wyman estimates that the modern car produces 19 terabytes of data a day. And so one big challenge is, and this is, AI tends to be data hungry, but one big challenge is figuring out how to use all this data.
Yeah, just to follow up on that quickly, yes, insurance companies are using big data to try to set premiums, but on the other hand, this is resulting in a lot of states imposing lawsuits on the very companies that are collecting this data. For example, OnStar is one such. I think several states have thrown lawsuits at them just from this insurance angle. But to also address the other point you raised, from a privacy point of view, I'm not talking about tracing every single person's daily decision process every day. It's more about getting a snapshot of it and building a model so that your computer model can predict that in the future and be sensitive to it, which is what the classical methods have always relied on. You need a small snapshot so you can build that behavior in, and then you can project that into the future. So hopefully it's not that much of a privacy consideration as long as you do this once in a while.
Great.
Anyway, thank you for your perspective.
Thanks, Rama. So maybe I think Ravi has a question, but I would request that we keep question and answers short. As it turned out, now we were originally planning to have dinner and then this session, but we had to reschedule a few things, and dinner is after this session, and people have been very patient, with us so far. But Ravi, you have a quick question?
Yeah. Anyway, Geeta, I'm a novice at this, so my questions can't be long. Taking on Rama's question and thinking about demand and supply side data being integrated to provide better solutions, today I understand that mood reading softwares are available. They read mood. And what do you think? AI will actually take these and build them into the transport or mobility solutions so that Rama's question could be answered partly?
Yeah, so I can tell you that I have a student group that I'm advising. They are trying to build, a system that can assess the mood of an individual to determine what type of music to play on the fly. So this is not a mobility related problem, but yeah, in fact, these are reasonably accurate, Ravi, and then the mood estimation are reasonably accurate, and they use, in important facial landmarks and speech and audio data from the individual to assess, and also the content of the text or the content of the audio to assess the mood, determine, what music to play and things like that. This goes back to, I guess, the intent of Rama's question, I guess, in some level, if there's an argument going on in a car and the system detects it, well, it knows that the individuals, if one of them is actually driving the car, they are not completely, following things. So it knows when it needs to sort of chime in and maybe help. Maybe it can slow down the car. Maybe it can, alert the driver that they're not paying attention or something like that. And these kind of things already exist. Like, for example, the most advanced ones that are on the market today can detect sleep, can detect, driver sleep or driver being distracted and things like that. So absolutely, I think these kinds of technologies could make its way into the personal experience of the user.
Thank you.
Thanks. So, by the way, Ajay, Ravi, and Rama have all been part of our core group, and they're very enthusiastic, when it comes to what we're doing at MInT. So, Ajay, final question is yours.
Yeah. So yeah, maybe just looking into your crystal ball, right? So like there's a lot of this LLMs are showing up, multimodal models. I mean, we only talked about like in general, about how we deploy them and being safe elements of it. But if you look at the application space, like where do you see like good opportunities to leverage these technologies for future?
Sorry, Ajay, you got, at least to my ears, you got cut off in
Yeah,
the middle,
Ajay,
so we didn't
in
get
between there was a
more
bit
your
of a
question.
distortion,
Yeah.
I think, right? So, I mean, to paraphrase, I think what Ajay was saying was LLMs, multimodal, models, right? Where do you see applications of these in, mobility, right?
Oh, I see. I mean, again, going back to something I said earlier, I think they can be used responsibly during the design process. Okay. So, as an aid or assistant to the design engineers potentially, as long as they're prompted carefully and you evaluate those. They can also be, I mean, they're already being used inside the infotainment center, within cars and vehicles as an assistant. And as the previous question suggested, I think from Ravi, you can potentially see them being used as a way to recognize when the human driver or pilot or whatever is distracted, and use that to maybe move into alert mode, so to speak, so that if the AI or the technology sees something coming up that needs the driver's attention or the pilot's attention, that will be provided in more, rather than being sort of on the side, would be more front and center, given the state of the behavior of the people in the car, so to speak. And so that is certainly something that is going to come. It's probably already happening at some level. But the biggest challenge is, with all this data that we're collecting, how do we bring it down to a few quick decisions that need to be taken? And that's, that remains the biggest challenge here, and especially in unforeseen environments. So how do you do it safely? So that's my response, Ajay, to your question.
Yeah, specifically on LLMs and related technologies, I completely agree with what Srini just said. But maybe on the urban planning side, if you start dealing with infrastructure, it becomes quite political, and a lot of social activity. And so we're increasingly working with urban planners and people in social sciences and sociology. So in terms of public engagement and stakeholder assessment and having interactions to these groups, because focus group, it's quite time consuming. It's part of the planning loop. And to speed that up, but while maintaining the buy-in of a broader society, we need much better tools for answering their questions and their concerns. And that technology seems ideal for that. Still, a lot of work needs to be done to ensure the quality of those responses. Because if you give them a strange response as part of a social engagement activity, that could stuff you up massively in your political delivery. So we have to get that to a level of assurance where it can engage with the public, in particular stakeholder groups. But then that could really be an ideal way of getting that part of the planning and delivery loop accomplished.
Great. I think we could keep going. There are a lot more interesting topics, but we're really grateful to both Professor Travis Waller and Professor Srini Parthasarathy. They've joined from Germany and Ohio State University, right? So it's great to have them here today with us. I also thank Ajay, who's himself an accomplished AI engineer, right? Ajay was with Waymo before, and I say he's doing way more cool things now as part of his Bedrock startup. So he's automating construction equipment, and I think I'm sure Ajay is also dealing with questions that Srini raised about safety, how to make sure the technology is foolproof before we deploy it. So Ajay, we'll do a tete-a-tete with you once, and we'll put you on the spotlight, and we'll ask you tough questions soon too. And of course, thank all the participants, all the participants, and both online and offline. There is one last question that we have from the audience here. Richa, yeah.
So I have a very interesting question from you. Suppose if you had to invest in any AI plus mobility startup today, what would you expect it be doing?
What would be an AI plus mobility startup you'll invest in? You can charge for this answer in terms of equity.
Yeah, so
and we are getting ready to buy stocks here based on what you say.
No, I should not talk about that. I'm already an advisor for a couple, so I'll sort of refrain from answering that question in specific terms. But more broadly, I think the way when you look at the entrepreneurial landscape, as I said in one of my remarks earlier, a majority of the effort on the user-facing stuff, the funding in the mobility space, mobility and AI, the intersection of mobility and AI space has focused on the user experience, the infotainment, those kinds of elements. And on the sort of mechanical, or not mechanical, but on the more sort of an other side of the equation where it's more, I guess, so it's more on the infrastructure, or the focus has been on, autonomous vehicles. So that's where the funding has gone. But if you're coming up with something new, you may want to work outside of those two, because there's already a lot of funding on those two. So if you have something new in mind from a startup perspective, try to think outside of the box, out of those two, because those are already extremely well funded. You're going to be competing against a lot of bright minds already. So if you want to, a professor of mine in grad school told me this way back when about, choosing problems. Try to choose a problem that the rest of the world has not figured out is a problem yet. Solve it. And then, that's a great recipe for a startup.
Thank you. Thank you.
Great.
Geeta, just a comment on what he said earlier about the concern for getting quick decisions. Srini, a few days back, IIT announced a company called Zero Labs, along with IIT and Pravartak, in very, very groundbreaking, path-breaking AI development, which will speed up the whatever you're talking about, reduce costs and so on. I suggest you take a look at it. ZIROH Labs.
I will be there visiting IIT later this year, so I will definitely take a look at that, Ravi. Thank you.
Yes. Yeah. So I think this year we'll have both Srini and Travis as well visit Chennai. So I think we'll all get to see more of them in person as well. So thank you so much, Srini, Travis, Ajay, Rama, Ravi, as well as all the audience. We are also going to have a small summary of the day, but I think I'm not going to hold you back, right? We will hit dinner immediately. I apologize we couldn't have a break in between because the schedule had to be changed because of others' commitments. We will go to dinner. Tomorrow is going to be interesting. Tomorrow is going to be a series of panel discussions. We start out with an architecture for DPI and mobility. Then we are going to talk about data and models, digital twins that we can develop. And finally, we'll end with what are the kind of applications, use cases we can solve with all of this, right? So it's going to be more exciting, very technical, right? And we'll also have highlights of projects we've done, right? And we'll have a break in between tomorrow. I promise you that. Thank you all. Thank you all for joining in. Good day, Srini. Good afternoon, Travis. And good evening to all here. Thank you so much. Yeah.
Geeta, if you don't mind,
Yeah, Srini.
sorry, if you don't mind, could you send me the schedule for tomorrow? I'm interested in some of those topics.
Sure, sure. We will circulate.
you don't
Richa
mind.
will get in touch with you. Yeah, we'll send it to you. Yeah.
Yeah, and I apologize for the technical difficulties at my end for getting in on this call late.
I mean, if an AA professor can have technical difficulties, then, you know,
No,
we're all
I mean, what do you do when
mortals.
the power is gone for the entire community? So
Thanks a
and
lot.
I had not charged my phone enough. So,
But thank you so much for joining. Thank you so much for joining in. Thank you all.
Thank you so much.
Bye. Thank you.
bye.
Thank you. Bye.
So dinner is served in the dining hall, right? Sorry to have kept you all waiting, but I hope you're hungry, you know, to have dinner. Thank you.